Welcome to this video on the Flutter Development Environment. After watching this video, you'll be able to describe the main components of Flutter development, identify the Dart programming language, identify emulators and physical devices, explain how the main components of Flutter work together. Flutter is an open-source user interface or UI software development toolkit. Developers use it to develop cross-platform applications by just writing code once. Flutter helps developers create native applications for iOS, Android, and the web with consistent UI. What makes this work is Flutter's main components. These include Flutter Software Development Kit or SDK, the Dart programming language, an integrated development environment or IDE, and emulators and physical devices. Let's explore those main components in more detail. The Flutter SDK is a collection of tools that developers need to create applications with Flutter. It includes the Dart SDK, which is essential for running and compiling Flutter apps. The SDK provides developers with everything required to build, test, and deploy Flutter applications. It includes libraries, tools for compiling code into native machine code, and tools for debugging. Flutter applications are written in Dart, an open-source programming language. Dart is optimized for UI development, making it an ideal choice for building fast and responsive apps. Dart's syntax is easy to learn for developers familiar with other programming languages such as JavaScript or Java. Dart also supports ahead-of-time AOT compilation, where Dart code is compiled into native machine code before the application is run for faster startup times. It also supports just-in-time JIT compilation, where Dart code is compiled into intermediate code, which is then interpreted and compiled into machine code at runtime. By supporting both AOT and JIT compilation, Dart provides the performance needed for production applications and the flexibility required for rapid development. Another main component of Flutter is the availability of IDEs, which offer features such as code completion, debugging, and emulation to streamline the development process. Popular IDEs for Flutter development include Visual Studio Code, IntelliJ IDEA, and Android Studio. Visual Studio Code is popular for its lightweight nature and extensive plugin ecosystem, while IntelliJ IDEA and Android Studio have more integrated tools and features for development. Flutter also supports both emulators and physical devices to help developers test applications. Developers can run and test Flutter apps on emulators, which are virtual devices that mimic various real-world devices and configurations. While emulators simulate mobile devices on a computer, testing on physical devices provides real-world testing environments. Emulators are great for quickly testing apps across different devices and screen sizes. Testing on physical devices helps developers examine the performance and user experience of the app on an actual device. Now let's examine building apps in Flutter to understand how these components work together. For example, imagine you're creating a to-do list application using Flutter. You create a new Flutter project using the Flutter SDK. This project includes the necessary files and folders to get started. The Flutter SDK provides a command line tool which is used to create new projects, run the app, and more. After setting up your project, you start using Dart to write the core logic of your to-do list app. This step includes managing tasks, adding new tasks, and marking tasks as completed. Next, you manage the state of your app using Flutter's built-in state management techniques. For state management, you use Stateful Widget to manage dynamic changes, such as adding or completing tasks. Effective state management ensures that your app responds quickly and correctly to user inputs and changes in data. After you've built your app in Flutter, you test your to-do list app on emulators and physical devices to ensure the app works smoothly across different environments. You use the debugging tools provided by your IDE to troubleshoot any issues. When testing and debugging are completed, you are ready to share your app with users. The Flutter Development Environment combines powerful tools and a robust programming language to help you build high-quality, cross-platform applications. By understanding these key components and how they integrate, you can effectively develop and deploy Flutter apps. In this video, you learned that the main components of Flutter development include the Flutter Software Development Kit, SDK, the Dart programming language, integrated development environments, IDEs, and emulators and physical devices. Flutter applications are written in Dart, an open-source programming language that is optimized for user interface UI development. Flutter uses emulators and physical devices to test the performance and user experience of apps on different devices. The main steps of building an app in Flutter include project setup, using Dart for logic, managing states in the app, and testing the app on emulators and physical devices.